In this video, we will cover the PLC programming. PLC programming is required when you have to handle a process. And remember, our process is a pump with a water tower and 3 networks with valves. In TwinSoft, you will define the PLC programming in the folder Programs. When you open Programs, you see we have one program called Main, in which all our process will be called. And this process can be divided in POUs. So we click Add a POU, and we see 3 different types of POU. First one is Program. It allows to divide our process into pieces. Okay, in order to avoid having a very, very big program, you define different pieces or sub-program. A function block is a functionality. So you will define a functionality like a pump management, for instance, and each time you need this process, you will call the function block and assign tags to the function block. Then the function is a calculation leading to one output. An example, percentage is a function that does not exist in TBox. So if you have to do a lot of percentage calculation, you could define your own function, and each time you need it, you call it. Let's create our first program, and let's call it pump. Use ladder language. We will see basic afterwards. We have 2 languages, ladder and basic. Let's keep ladder and click OK. Then I double click on pump and I enter into ladder. Ladder is represented by 2 lines called rails representing electrical wires. And you can imagine if you put switches and relays between these, when the switch is closed, the relay will be activated. When I am in visualization, I can do 3 things. Add a new rung, which constitute a line of process. Add a new command, which is a text, which is very important to comment your code. And a label, which you can use to jump to part of the program. To insert a new command, you double click command and you type your text. Then to insert a process itself, you can either click on this add a new ladder line, or easier, you just double click and you enter into a rung edition. Then you see you have a grid, and on the grid you will insert object. Let's take a look to the first 2 lines of object from our document. So the first line of object are input conditions. So they represent switches. And the second line represent relays, okay, which are outputs. So let's take a look in detail what it represents. So the first contact is called normal input contact. So when the tag associated to this contact is 1, the current going through the object. Then we have an inverted input contact, or corresponding to a normally closed switch. When the input is 0, the current will go through the switch. Then we have edge input contact, positive edge and negative edge. For those, they will have a pulse. Just when the tag change from 0 to 1, we have a pulse, positive edge, negative edge. When the tag change from 1 to 0, we have a pulse. Then we have the relays. We have a normal relay. When it is 1, the relay is activated. When it is 0, the relay is activated. Then we have a set. The set maintains the tag to 1 when receiving a pulse. Then we have a reset. It maintains the tag to 0 when it receives a pulse. Usually we will associate the edge input contact with set and reset. Let's go back to our program and let's make our first line. The first line will be starting the pump. So remember, into our list of tags we have a tag start, a tag stop and a tag pump. So we will associate those tags to activate the pump. So I enter into my line of ladder and I will insert object. Now the start is a push button. So for a push button I will take an edge contact. So I click the contact. Now you see the cursor has changed, and when I click into this cell here, it inserts a contact and I have to associate a digital tag. I go to my list of tags and I take start. Then I have to activate the pump, so I select my relay, and because I work with the edge contact, I will have only one pulse, and this pulse has to be maintained, so I will use a set relay. I click next to my input, it draws the lines, and I select my tag pump. And my first line is done. This line has to be compiled, so for the compile I have this object here, and I am ready for the next line. So the next line is to stop the pump. So I have another button, which is also a push button, so I select my object positive edge, insert here, select the tag stop, and then I will put the pump. Now imagine that I click here and I have here no line. There's not an issue because we can draw a line afterwards, and I select the pump. So if I try to compile this line, it's refused because this line is wrong. Okay, we cannot produce such a code for this line. So the line needs absolutely to be closed. So for this I have an object here, lines, and to draw a line, it's not like with a pen where you have to go exactly on the lines. The line is drawn when you cross cells. So I click here, I maintain the button, and when I click, I cross a cell, you see the line is drawn. And then I can go further. Now if I want to change direction, I release the button, I click again, and I go down, down. I click again, I move. Okay, my line is closed, and this is accepted. Okay, it's a little bit strange design, but it will work. Now test our lines. First I have to quit edition because I'm still in edition here. So I can press escape and I return into visualization. Now one big advantage of ladder logic is that digital tag or Boolean operation are visible as a green block. So if I activate my start, you see it indicated by a green rectangle, and the same for the stop. Now my program doesn't work, so here it is supposed to activate the pump, but this doesn't work because I need to send this to the TBox. But remember also that the only program which is known is the program main. Everything has to be called from main. So I have to go to main, and this program pump, I have to call it into main. So I go into edition, I click the object here, program function block, I click next to the left rail, I see in this I see a series of standard function, and I have a folder, this file, in which I will see my first program pump. I select it, it calls the block pump, and then I have to close the line. Remember, always close the line. Sorry. Accept changes, escape, and then send to TBox. Sending is complete. So I double click inside my block, I enter into my program, and so I use my simulation card and the switches, so I can give pulse. So if I give a pulse to the start, you see a very short pulse on the start, my pump is started. I give a short pulse on the stop, and you even didn't see the stop, it still stopped. So I start again, I give a pulse to the start, I give a pulse to the stop, and my pump is started and stopped. This is a basic handling of the pump without any monitoring of pump temperature or water level, and only manual action. So let's adapt this code in order to take into account the temperature of the pump and the level in the water tower. First I will reduce this window and I will update the lines here. So if you want to edit a line, you just double click in the line, you enter back into edition, and then you see when you move you select object, and you can just delete object, delete object, delete object, and I will draw a new line. OK, and I press accept changes. I will edit the lines to add an automatical mode and also an emergency stop. So I need more tags. So I will go back to my list of tags, and the tags will be inputs from the simulation card. So I go to I/O, simulation, digital input. I will add this before last will be the tag to switch between auto and manual mode. And the last one will be the emergency stop. So I have the tags I need, so I can go back to my program. So to edit the line, I just double click the line. So these lines here correspond to manual mode. So manual mode means not automatic mode. So I set the negative input contact and I associate it to the tag auto. If you know the name of the tag, you can type the name. If you don't know the name of the tag, you can click the 3 dots button and you select the name of the tag. If the tag does not exist, you even can create it. So if I know it's called auto, I can just type auto and the tag is accepted. When you place two objects in series, you make an AND operation. So to activate the pump manually, you need to be not in auto and to push the button start. Now the automatical mode, it's an OR operation. So it is this one or an automatical mode that I will insert here as a new line. So I will first start by putting the auto button. So when I am in auto mode here, I put the normal contact. I will draw the line, and I need to have the temperature of the pump, let's say, below 50 degrees. If it's below 50 degrees, I accept to start the pump. So I will insert a function, a comparison function. Here we have the analog function and we have all the possible comparison function. So if the temperature is below, so A smaller than B, okay, A represents the temperature of the pump, B a constant which is 50. So I select a tag or a constant. So I click on the 3 dots button, I take my pump temperature, and here I just type a constant, 50, enter. And I will move my object to the right position so that I can draw the line. And I close the line. Another condition is that the water level is below, let's say, 3.5 meters. Remember, we have a water tower of 2 to 10 meters. So if the water is below 3.5 meters, I want to activate the pump. So once again, I select the function object. I click here. If A smaller than B, okay. Now it will be the water level below 3.5. I just type the constant, enter. And I close the lines. Last information I need to insert, the emergency tag. So the emergency is a normally closed contact. So I will select this object here. And I will select the object in this position because the emergency has to prevent starting the pump as well as in manual mode or in automatical mode. And I select the tag emergency. Okay, the line is finished. I compile to check it's correct. I can click here, accept changes. I can also, if you prefer to work with keyboards, press plus. So I return to visualization mode, and you see that the comparison function is a Boolean function. So it's a true or false function. So if I activate the potentiometer, we can see the result. The comparison is true or false. Let's now adapt the stop activation to support manual and automatical mode. So to edit the line, I double click the line, so I can insert a switch. So I take contact and I place the cursor where I want the contact. I type the name of the tags. I close the last line. Okay, so this is my line to stop in manual mode or automatical mode. Oh, I see I have done a mistake here. You see, I did not select the right contact. It should be a normally open contact. If this is the case, you can just select the right contact and you click on the object and it's updated automatically. Okay, so let's accept this line and let's now send this to TBox to see the result. As you can see, I have shown the image of our TBox so that we can see the result as we are manipulating the IOs. Okay, so here you can see that I am in automatical mode. So automatical mode is a switch that I have here. I can change from automatical to manual. So when I am in automatical mode, if I activate the start button, which is this one here, you see nothing happens because this line is open. The emergency is closed. So if I manipulate the two potentiometers simulating the pump temperature and the water level, I should be able to activate my pump. So it seems like my temperature is a little bit too high. Okay, now it's go down and the water level is too high, so I will go down to less than 3.5 meters and then the pump will start. Okay, pump has now started. Okay, as you can see, I am manipulating IOs, but I have absolutely no visibility on the values. So let's see how we can see values. The first thing you can do is when you put the cursor on the tag, you see on the bottom here, look at the bottom here when I will move the cursor. So the cursor is the temperature of the pump. I see 31.6. If I turn the potentiometer, you will see this temperature increase. And when it's above 50, the comparison opens. Water level. I turn the potentiometer and you see the water level increase. Okay, another way we have to display several tags at the same time is the watch window. You see here at the bottom we have 3 windows, result, watch, cross-reference. So in the watch window I can add tags. So I can add, for instance, the pump temperature and I can add the water level. So all the time I will see those 2 tags in my watch window. So I have at the same time visibility on my process and on the values of tag. Other possibility of displaying tags is displaying multiple window. So I have a window menu, I can make new window, I select my list of tags and then I can display the windows horizontally and I see my list of tags at the same time as my process, and I can change the size of the window. Okay, so I see my list of tags and I see at the same time my process. To continue, let's maximize this window and display back our project workspace. Here we are. Next feature I would like to discuss are the timers. So the timers are embedded functions which you can use in process, either ladder or basic, and you define the timer instances into the folders here from the resources. We have timers and we have counters. Both function works the same way. The difference is that a timer you activate it, and once activated it runs on itself. A counter, each time you activate the counter, it will increment or decrement. In our process, I would like to handle a maintenance. So when I start the maintenance, I would like to deactivate some features of TBox, and to make sure that I do not forget to stop the maintenance status, I will start a timer that the features are reactivated automatically after a certain time. For this kind of things, I can use a timer. So let's open our document to see how a timer works. So the input here, chart, shows the activation of my timer. So when I want to start the maintenance, I will activate a switch, which is the maintenance switch. This switch will start the timer. So the timer will start counting, and the timer starts counting in milliseconds. So the resolution of a timer is millisecond. Associated to the timer, there is a digital tag, which is the state of the timer. So when the timer starts counting, the state changes to 1. I would like that when I am in maintenance status, a lamp is on to inform the site that we are in a maintenance status. So this digital tag will activate the lamp. So as long as I am in maintenance, the lamp will be on. When the timer will start, I will deactivate some features, and when the timer stops, I will reactivate the features. Here we have a single shot timer. So each time you reactivate the timer restarts. So you see here, I reactivate the timer before it ends. So it restarts, and the state of the timer stays on as long as the timer is active. Let's configure that in TwinSoft now. First, I have to create an instance of the timer, because the timer is a function, but if I need 1, 2, 10, 20 timers, I will use the same function but with different instances, meaning different variables associated to my timer. So I go to the folder timers, I click add a timer, and I call it T maintenance. And you see, when I create a timer instance, I have the possibility to declare 3 tags. It's not mandatory, because the tags will be available as internal variable, but if you want to access this information, you have to tag it. And in my case, I want to use the state of the timer to activate the lamp, as long as the state is on, to deactivate feature when the timer starts, and to reactivate features when the timer ends. So I need a tag associated to this information. So I will create a tag. So here status. If the tag does not exist, I click on the browse button. I can make new tag. It's a digital tag, and I call it T main status. No initialization, the timer initialized at the starting of the TBox. Okay. Okay. So my timer instance is ready. I can now make the code to activate this timer. Now we need a new tag to start the maintenance. So I go to my resources, simulation, digital input. So let's take this one here. Okay, it's maintenance. Okay, Let's go into my list of tags. Okay, I start having quite a lot of tags now, so I will rearrange my list a little bit so I can make a new group. For instance, I can make GSM, and I can move all the tags associated to the GSM there. And I can make another group which is IOs, for instance, and then I will move all the physical IOs to this folder. So the pump, the valve here, the flow, no, not the flow, the valves, auto, emergency, and maintenance. Okay. So in this folder I have all my IOs. Now let's go to the process. So I will make a new line, and this line will be a line of command. Okay, this is maintenance. Okay. Now my button maintenance will activate a timer. So I make a new line. I select my tag maintenance. It's a digital tag, so I take a digital contact, maintenance, and the timer is a function. So I select the object function, I click on a cell, and I have a folder timers, and then I have 4 models of timers: single shot, retriggerable timer, monostable, not retriggerable timer, integral timer, and on delay timer, and finally a reset timer function. I select single shot. I select my timer instance that I have created, which is the maintenance one, and the preset. The preset is, as you can see, a constant in seconds. So even if the timer counts internally in milliseconds, remember, so if I want to make a 2.5 seconds timer, I will type here 2.5. Okay, if I want to make a timer of 2 hours, it is 7,200 seconds. Okay, I close the lines, and I close the line here also. This point here does not represent the status of the timer. The status of the timer is a digital tag we have created. So if I want to have action on this status, like activating the lamp, for instance, I will act directly on this status tag. Let's compile the next rung. So I want to switch on the lamp when my timer is active. So when my timer is active, remember, the status of the timer is 1. So I just take the positive contact, select the timer status, and select a relay with the lamp. So as long as my timer runs, my lamp is on. Go to the next line. Now I want, when the timer starts, to deactivate some features of TBox. So the feature I want to deactivate is some recording in data logging and some alarm settings. Remember that when we define data loggings, we have an enabling, okay, here for instance. So the logging of the opening and closing of the door. The handling is disable if this CRD and this CRA is 1. Okay, and this CRD, this CRD, those are system variables that I can find here. Disable chronology recording, disable analog chronology recording, and we have the same for alarm, disable alarm. I will activate those flags when I am in a maintenance to deactivate the recording and the alarms which are associated to this handling. For instance, in my alarms, if I go to my alarms, conditions, I could say the level of the tank. I don't want to generate an alarm when I am in maintenance because, well, I might empty the water tower. So I select this alarm condition, and in the handling I say select disable ala equal 1. And when I am in maintenance, I will set this flag to 1, which will disable temporarily this alarm. Okay, let's go back to my program. So when the timer starts, and when does the timer start? It's illustrated by this positive edge trigger. So I have a pulse when the timer starts, and with this pulse I will set my system variable. So you see that you can access the system variables directly without tagging them. So I go to disable CRD, disable CRA, and disable ALA, and I close the line. I accept changes, and I'm ready for the next run. The next run will be the contrary. So when my timer ends, I want to reactivate. So it's the invert of this. It's negative edge contact and it's reset. So I can just make a copy paste of this line, Control C, Control V. I edit the line, and remember we can change the type of object here. So if I select here the negative edge contact and I click on the contact, it changes automatically. I click here reset, and I click reset, 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 accept changes, and my line is done. Last line, when I end the maintenance. So we have seen the goal of the timer is a security if I forget to stop my maintenance button, so that my features return back to normal if I forget to switch off the maintenance button. Now, if I switch off effectively the button, I have to reset the timer. So let's make this line. So negative edge on maintenance button, meaning I open the button, will reset the timer. A reset timer is a function. In my list of functions, I have a folder timer. I have a function reset timer that I reset, and I select the instance of timer I have to reset, and I close the line. This ends my program for the maintenance. Let's now send to TBox and see the result. Sending is complete. So let's activate the maintenance button. So my timer has started, indicated by the status which is on, and my disabling features have been activated. After 2 hours, automatically the timer will stop. So those will go to 0. So it will reset those flags. And the timer will be reset if I manually stop the maintenance. Stop the maintenance, everything is restored to normal. Let's just take a look to the other variables associated to the timers. Remember, when we have created the timers, we have seen 2 other tags that we could associate to the timer with a value and a preset. It's not mandatory to declare them, but just let's do it to see what it makes. So the value of the timer will give me the number of milliseconds it is counting. And this tag must be a 32-bit unsigned tag. So I call it main value. It's 32 bits unsigned, because it will give me millisecond. The same for the preset. I can make a new tag, analog. It's the main preset. It's also a 32 bits unsigned. The fact that I have created the tag preset will allow me to change dynamically the preset of the timer. At the moment, the timer, I have set it to 2 hours, but if I want to change it to 1 hour, by writing into this tag, I will be able to change it. The tag value will return me the counting of the timer when it is activated. So let's see this. Send to TBox. Program has been sent, and I have added the value and preset of the timer into the watch window, that we can see the value at the same time as we run the program. So if I run the maintenance now, you see my value is counting, and it's counting into millisecond. The preset is also expressed in millisecond, 7,200,000 millisecond. And you see here the progression of the timer. If I stop the maintenance, it will reset the timer and everything is restored. Now, let's imagine, okay, I would like to test the automatic activation of my timer. I would like to test my timer stopping itself. So I can just change the preset to, let's say, 5 seconds, that I don't have to wait 2 hours to say it works properly. So I just select the tag, press F4, put 5,000 because I have to indicate a time in millisecond. Now the preset is 5 seconds. So if I activate my maintenance now, after 5 seconds, it will end. 2, 3, 4, 5. Done. So you see, my maintenance button is still active, but my features, they have been reactivated. The lamp has been stopped, even if I have forgotten to release the maintenance button. Some more features to show you about ladder. So we haven't seen any mathematical operation in ladder. It is possible. We have for that an object which is here a mathematical block, which allows you to do a series of arithmetic operation, bit and Boolean operation, and some miscellaneous function. Using BASIC, you will have many more mathematical functions available. Advantage of ladder is that you have a visibility on the Boolean status. So when a Boolean status is on or off, you will see it in ladder logic. Other features I can show you from ladder is the cross-reference. So you see we have a tab here, cross-reference. If I select a tag, let's take for instance a water level. If I right-click the tag, I click cross-reference, I see everywhere the tag is used. First, I see in which folder of tags it is. Then I see in the programs in which line it is used. I see it's used in alarm condition and sampling table. I just double-click on the line and it jumps to its entry in the associated configuration. Okay, this ends our lessons about ladder logic. So let's go to the questionnaire. As usual, use the same application. From the IOSimul, you create 3 new inputs: auto, emergency, and maintenance. You reorganize the list of tags by adding 2 groups of tags, GSM and IOs, in which you add their respective tags. You create a timer instance. You associate to it a digital internal tag as status. You create a POU program you name pump, and in the program main you call this program pump. In the program pump you create the ladder as in the video to stop the pump with a manual and automatical mode, and you create the ladder as in the video to handle the maintenance with the activation of system variables, with activation of a lamp, and with using a timer to make sure it returns to normal mode after maximum 2 hours. Don't forget to send regularly the program to TBox and check the result. Finally, send us the application. Good luck!